Hello, my friends. This is Dr. Alex again, and today we will keep focusing on the digital circuit analysis. So let's look at this problem. So the first one is let us to rewrite this function and use this thing, which is called canonical. Okay, canonical. Yes, canonical. So first of all, the key to solve this problem is to understand the meaning of this term, which means each section of the original function should contain all the variables, okay, all the variables. And we can see the original function, which is t equals b, or a and not b, not c, or not a and c, all right? Yeah. For the first section, sorry, for the second section or second item, it contains all the three variables A, B, and C, okay, or three gates, okay. However, the first and the third items, they don't have all the three gates, okay, or variables. For the first item, it lacks the variable A and C, and for the third term, it lacks the variable of B. So we just need to make the integrate as the required of the term canonical. All right. How to add the missing variables? Okay, because we know this expression x or not x is 1. All right. So we can rewrite the first term as this thing. Okay, because this term is 1, this term is also 1, and all these three items, when they AND each other, the result will be the same as B. However, we can get the canonical expression for the first term, which is like this. We just write the expression after my calculation. Yeah, you can double check it. And for the third item, which is not A, and sorry, and C, okay, and C. We just make it like this, okay. We can get the canonical expression for the third term, which is not A, B, C, or not A, C, not B, okay. We just put all the three items together. We can get the result for the first question. All right, that's quite straightforward. Now let's move on to the second question, which is asking us to use the De Morgan's theory to simplify this expression. So first of all, and most important, we should understand the theory of De Morgan, which is quite straightforward. You see, we can see A or B and not equals not A and not B. Similarly, if we get it like this, the not of A and B equals not A or not B. All right? Yeah. Okay. Let's apply the De Morgan theory to this expression, which is like this. Okay. Not A and B or A, D, and like this. All right? Okay. Under the not gate, we have three items. So we can make it like this, right? Okay, that's the first step. And then we make it quite clear, which is like this. The first item can be rewrite like this, okay? For the second one is expressed like this. And for the third one, double not is the original one. So it's just C and D, all right? Okay, let's multiply these two items together, we can get this expression. A, not D, not A, not B, not B, not D, okay? Together, and CD. So we just multiply the CD into the first thing, we can get it like this. It's quite straightforward. Okay, as we mentioned before, any variable, any Boolean variable, when the original one and the not form, it should be always there. So the first term and the third term should be there. So the final and simplified form for this question is not A, not B, C, and D. This is our final result. All right, hope everyone can learn something from my explanation. And hope everyone be happy and be safe. Thank you very much. See you next time. Bye bye.